In today's session, we will discuss some of the most important and frequently asked questions on the BJT and associated circuits like biasing techniques, common emitter, common base configurations, and amplifier analysis. All these question models are based on the previous year examinations of GATE, IES, ISRO, DRDO, Polytechnic Lecturers, and other state public sector unit examinations. Let's welcome to the channel Electronics Pariksha. Let's see the question. Calculate the value of emitter current I for a BJT with alpha DC is equals to 0.99 and base current IB is equals to 40 microamperes. So here base current is equals to 40 microamperes and alpha is equals to 0.99. He is asking us to calculate emitter current I. So emitter current is nothing but base current plus collector current. Collector current can also be written as base current plus beta IB. So emitter current IE is equals to IB 1 plus beta. We know that beta is equals to alpha divided by 1 minus alpha. So substituting the values 0.99, 1 minus 0.99 gives us beta as 99 value. So emitter current IE is equals to base current 40 microamperes multiplied by 100. So it will be 4 milliamps. So answer is option C. We'll see the next question. Calculate the value of emitter current for transistor alpha DC is equals to 0.98 and IB is 100 microamperes. Same problem. Similar model problem. Alpha is equals to 0.98, IB is equals to 100 microamperes. He is asking us to calculate the emitter current, which is equals to 1 plus beta IB, whereas beta is equals to alpha divided by 1 minus alpha. So substituting the values 0.98 divided by 1 minus 0.98 gives us a beta value as 49. So if you substitute these values, IE is equals to 49 plus 1, that is 50. Base current is 100 microamperes, which gives us 5 milliamps. So emitter current is equals to 5 milliamps. Answer is option A. Next question. In an NPN transistor, if the base current is 100 microamperes and current again beta is equals to 200, the collector current is, it's really very simple. The collector current IC is equals to beta IB. So IC is equals to beta value is 200, IB base current is 100 microamperes. So you'll get collector current IC as 20 milliamps. So answer is option D. Next question. For the silicon transistor shown in the figure below, the value of a base current IB is. So this is the transistor circuit. We have got VEE. VEE is as minus 8 volts and VCC as 10 volts. So he's asking us to calculate the base current. So apply the Kirchhoff voltage law in the input loop. If you apply the Kirchhoff voltage law in the input loop, in this loop, if you apply the KVL in the input loop that covers the base emitter junction, you can write this as like the video, share the video, and subscribe to the channel for better content and more videos. Apply the Kirchhoff voltage law in the input loop of the base emitter junction. In this direction, you will have first VBE as 0.7, and then comes IERE, the voltage drop across the emitter resistance, and then VEE. So take it similar, VBE plus IERE plus VEE is equals to 0. VBE base emitter voltage junction voltage value is 0.7. IE we do not know, emitter current is not known, emitter resistance is 2.4 kilo ohms. VEE is nothing but 8 volts. So if you solve this, the emitter current IE is equals to, it will be around 3.042 milliamps. This is the emitter current that we have. So we know that the emitter current is nothing but sum of base and collector currents. This can also be written as beta plus 1 IB, because the collector current IC is nothing but beta IB. So now here, this is IB. So now here, the base current can be written as IE divided by 1 plus beta. Emitter current is known 3.042 milliamps divided by beta value is 100. It is given in the question itself. So substitute the values. You will get base current IB as 30.11 microamps. So the answer is option D. We'll see the next question. Determine the base current of amplifier by taking the base emitter junction voltage into account. So if you see this question, he's asking us to find out the base current. To find out the base current, just apply the Kirchhoff voltage law, KVL, in the input loop. That is like this. Apply the KVL in the input loop to find out the base current. So by KVL at input loop, you will get VCC is equals to IB RB plus VBE. The base emitter junction voltage is 0.7, we know that. So 12 is equals to IB into RB is 100 kilo ohms. So 10 to the power of 5 I am writing here plus 0.7 volts. So base current IB is equals to 12 minus 0.7 divided by 10 to the power of 5, which will be equal to 113 microamperes. So answer is option C. So next question. A transistor has a base current of 200 microamperes and a collector current of 550 milliamps. Find the beta value. Beta value is equals to the collector current divided by base current. So collector current is given as 50 milliamps and base current is given as 200 microamperes. So the beta value will be approximately 250. So answer is option D. We'll see the next question. A microphone is connected between the base and the ground of BJT. A 1 kilo ohm resistance is connected between the collector and VCC. So it is like this. This is VCC and a 1 kilo ohm resistor. That is collector resistance RC is equal to 1 kilo ohm resistor. This is the transistor. Is telling a microphone is connected between the base and ground. So here that microphone is there. Base and ground. This is the microphone. So basically this is an amplifier. It is taking the voltage from microphone and giving the load to speaker like that. So if IS is the reverse current. So reverse current flows basically in the collector. So IS is the reverse current that is flowing in the transistor. And the peak value of a microvolt signal is 20 millivolts. So here the applied voltage is 20 millivolts. What is the peak value of output signal? Output is taken here. So what is the peak value of output signal? This is what he's asking. Now let's try to solve this. So the output voltage is nothing but the output current, collector current, multiplied by resistance. Output resistance is collector resistance. To calculate the collector current first, the collector current can be given as IS e to the power of VD divided by eta VT minus 1. So VD is nothing but the voltage drop across the junction, which will be equal to the microphone voltage. If you apply the Kirchhoff voltage law in this loop, the same 20 millivolts will drop across the junction, base emitter junction. Eta is by default it is taken as 1. VT is the thermal voltage, that is 26 millivolts. By substituting these values, we'll see 16 to 10 to the power of minus 16. E to the power of VD is 20 millivolts divided by 26 millivolts. That is the thermal equivalent voltage, 26 millivolts minus 1. So you will get, if you calculate this, you will get collector current as approximately 6. It will be 1.29 into 10 to the power of minus 15 into 10 to the power of minus 15 amperes. So if you substitute this value in the output voltage formula, output voltage is equals to 1.29 into 10 to the power of minus 15 into the collector resistance is 1 kilo ohm. So you will get approximately 1.29 into 10 to the power of minus 12 volts. This is the output voltage. So answer is option C. Like the video, share the video and subscribe to the channel for better content and more videos. So next question, for the circuit shown in the below figure, by assuming beta is equals to 100, VB is 0.7. So VB, the forward voltage drop across the base emitter junction is 0.7. Beta is equals to 100. The best approximation for the collector current IC in the active region is, right, he has given the beta value. So we can easily find out the collector current from the base current. So apply the Kirchhoff voltage law in the input loop. by applying KVL in input loop. Because beta value is given, if we know the base current, you can easily calculate collector current. You will get the base voltage 12 is equals to IB into RB plus VBE plus IE into RE. So 12 is equals to, the base current is not known. So this IE you can write as 1 plus beta into IB. So if you calculate that, okay, let's write down simply IB into RB. RB is 10 kilo ohms plus VB is 0.7 volts. Emitter current can be written as 1 plus beta into IB. Emitter resistance is 0.45 kilo ohms. So here 1 plus beta can be written as 101. So the unknown parameter is the base current IB. So 11.3 is equals to 10 kilo ohms plus 101 into 0.45 kilo ohms. So by solving this, the base current will be 0.02432 milliamps. So the base current is known. Now the collector current IC is equals to beta into base current. So if you substitute that, beta is 100, base current is 0.0243 milliamps. You will get the collector current as 2.53 milliamps. 2.43 milliamps. So the answer is option A, which is approximately closer to this. Next question. An NPN transistor operated at IC is equals to 5 milliamps has a collector load resistance of 2 kilo ohms and its emitter is grounded. The voltage gain of this stage is, so it's basically like this. This is the transistor. Emitter is grounded. There is no emitter resistance. There is a collector resistance. Output is taken here. The input voltage is given as this, thermal equivalent voltage, VT. So collector current IC is given 5 milliamps. Collector resistance is given as 2 kilo ohms. So the voltage gain basically is output voltage divided by input voltage. Here the output voltage is simple, collector current multiplied by collector resistance. Input voltage is nothing but the thermal equivalent voltage. So by substituting these values, you will get the answer. The thermal equivalent voltage is given as 25 millivolts. So here the voltage gain will be 400. So the answer is option B. Next question. Assuming VC saturation is 0.2, beta is equals to 50, the minimum base current IB required to drive the transistor into saturation. So here what he's asking for the minimum base current. So let's calculate that. If you apply the Kirchhoff voltage law in the output loop, you will get, by applying KVL in output loop, VCC is equals to IC RC plus VCE saturation. So what is VCC? 3 volts. The collector current is not given here. So IC, the collector resistance is 1 kilo ohm. VC saturation is given as 0.2. So if you substitute this, the collector current will be 2.8 milliamps. So from this you can calculate the base current. This is collector saturation current. So the base saturation current is collector saturation current divided by beta. So 2.8 milliamps divided by 50. You will get it as 56 microamperes. So the answer is 56 microamperes.
Sri Raghava Academy online coaching center for the regular and backlog students dedicated to diploma and engineering courses. Semester wise and subject wise coaching is available. Contact the number 70192 46753.